along the way. You can see those team members have a bit of a hike to carry it to where it is safe operationally. And you can see we have the cargo netting already laid out there. Our representative from Dugway, Jasmine Nakayama, is prepared with that cargo netting. She's going to help the team here get that SRC that has already been successfully bagged up with thermal wrapping into that cargo netting. And you can see the helicopter already there, staged and ready to lift off. The helicopter pilot has actually removed one of the doors on that helicopter so he can lean out and look down as he carefully lifts the SRC off the terrain. We want to make sure that this is a careful, slow process as we safely transport this SRC to the Dugway clean room. And you can see Jasmine is picking up pieces of the cargo netting and beginning to wrap the SRC that has been placed already on the carrying fixture with the thermal blanketing. Team members observing their handiwork of getting that carefully wrapped up. We'll then actually unwrap all of that thermal blanketing once we actually get it into the clean room here.
Recovery operations, SRCs in the cargo net, and all the gear has been stowed in the helicopter.
Great news, everything sounds nominal for helicopter operations, and in just a few moments we should have liftoff of that SRC aboard the helicopter with that long line attached. Team members clearing the area to make sure that we can safely take off with our helicopter. These helicopter pilots have also been training in tandem with all the team members the past couple months leading up to this key moment. We've practiced these long line operations, we've practiced the flight back to the Dugway clean room, but obviously nothing compares to the real deal. I'm sure they are feeling the excitement, they are feeling the nerves as they know how precious their cargo is this morning that they're transporting to the Dugway clean room. See, Jasmine is donning a helmet and the rotors are kicking on for our helicopter. Kicking off some dust as they get up to speed there. It is a dusty morning out on the desert. And this will be, once again, a very slow, deliberate operation. We want to make sure that sample return capsule is safe as we are lifting it off. The piece that Jasmine is holding in her hand right now is that gimbal stabilizer for the cargo netting. That will ensure that the SRC is not wildly spinning as we get to altitude with our helicopter. These helicopters can get upwards of over 100 miles an hour speed, but we're going to go nowhere close to that today. We're going to be taking this at a slow pace, making sure that SRC can get back safely and securely to our Dugway clean room. You can see one of our NASA photographers, Keegan Barber, taking some great pictures. I'm sure those will be phenomenal views of the operations that are going on just across the way from us at the Utah Test and Training Range. As soon as these rotors get up to speed, our helicopter will get off the ground. The terrain is a little bit soft today. Team members were out here yesterday testing out the grounds and had practiced actually landing with some of the helicopters. Those skids on the helicopters got about an inch into the wet terrain. It's presumably dried a lot more today. It's the sunny, clear skies have probably helped us out a bit, so this should be an easy liftoff for this helicopter to get into the air and help transport that SRC to the clean room. Off-screen, team members are presumably continuing to collect samples of the surrounding area, both environmental, soil samples, atmospheric samples. We'll be continuing to do those operations even as we bring this SRC to our clean room. Just a great view here from our NASA helicopter. And in just a few moments, we should have a stunning view of our SRC lifting off the ground. No part of this SRC comes in contact with the helicopter. As I said, it's been safely stored in that thermal blanketing. There's multiple layers of that blanketing, as well as a tarp being placed over it. Now it is also in that cargo netting, thanks to our Dugway representative, Jasmine Nakayama. She's then attached this whole contraption to a long line that will dangle about 100 feet below the helicopter. And I can see a lot of dust kicking up now. The engine's really revving up on that helicopter, and it is off the desert terrain in the air with the SRC in tow.
Recovery operations. Helicopter 1 is cleared to depart the recovery site with the SRC.
And we have clearance to depart the recovery site. This is a key moment of those recovery operations. We're already getting that SRC out of the landing zone and on its way to the dugway clean room. In just a few moments, that SRC with the long line attached will be lifting off its landing zone. Jasmine assisting with that final part of the lift, and it is now airborne. As I mentioned, a much more relaxing flight for our SRC on its last leg of its journey. We are officially departing that landing zone. Recovery operations will continue out at the dugway clean room. I see team members waving goodbye. And look at that view. This is a stunning view of our helicopter. This is a long journey ahead. As I mentioned, probably about 20 minutes of total flight time. We may lose signal as we head out there a bit, but for now we have a stunning view of our helicopter carrying the SRC below, and you can see that stabilizer is helping to keep that SRC nice and stable below. We'll continue to track this transport to the clean room, but for now, back to you, Lauren and Jim.
Wow, check out that epic shot. Check it out.
What a ride.
Wow. All right. Thanks, James. The science community has serious questions about asteroids like Bennu for a long time. What are they made of? Do they hold any clues about the origins of life on Earth or elsewhere? And what can they tell us about our past and potentially our future?
It's all about chemistry, Lauren.
It absolutely is. Well, fortunately, Jim, we are joined by somebody who specializes in the kind of chemistry that you'd be hard-pressed to find outside of NASA. Jason Dworkin is the OSIRIS-REx project scientist. Welcome.
Welcome, Jason. Thanks for
coming.
coming.
And congratulations. What a historic day.
Oh, it's
You
just
must be so relieved.
fantastic, yes. Relieved, invigorated, excited, and
As we
so
all
much
are.
work ahead of us.
Right.
Indeed, indeed.
Fun work.
Fun
Oh,
work.
no, epic work.
Epic work. You must be so excited to dig into the sample yourself. But what makes this sample? You know, we've continued to say this is such an important sample from an asteroid. Why is it scientifically significant?
So Bennu is an ancient piece of the early solar system, a leftover component. It's a fragment of what happens when you make planets, and this fragment of rock it contains the ingredients that happen when you make planets, that happens when you make life. Right. So by studying a sample from the leftovers of space, we can study a sample from the leftovers of the formation of the Earth. Look at the chemistry in detail as you can only do on the ground using instruments that are sometimes bigger than a launch pad, let alone the rock and the spacecraft. So we can interrogate the compounds, the minerals in fine detail to understand how they interact with each other and how they could have led to the history of the solar system.
And that's forensic science at its best. But I have a question, Jason, because you're an expert in this. So we're going to save some of this sample so that future generations, future techniques, future people not even born can learn from it in the future as we try to look at our place in space.
Absolutely. That's one of the parts I find the most exciting and gratifying, is that the work we do here will be available for scientists perhaps watching now, perhaps not yet born. They can make choices and come up with their own hypotheses, their own ideas, their own new techniques to look at the sample in new and exciting ways, just as we have for the Apollo samples. A woman in my laboratory studied Apollo 16 and 17 samples that were collected before she was born, using techniques that were not invented in the 1970s to then answer questions that were thought of but couldn't be answered.
That's
and so
incredible.
Since you mentioned forensics, we also have equipped future generations with the information to follow the chain of evidence from the construction of the spacecraft all the way to the collection now and then the distribution.
Awesome, Jason.
Wow, that is so cool.
Thank you.
Well, thank you so much for joining us.
Pleasure. Thank you.
Thanks, Jason. Good luck.
Careful handling of this asteroid sample is all about getting the most out of the huge effort to visit the object in the first place. Mission planners considered many destinations but settled on Bennu. Let's learn more about why. OSIRIS-REx was designed to retrieve a sample from asteroid Bennu and return it to Earth. So, of the more than 1 million known asteroids in our solar system, why Bennu? First, as a near-Earth asteroid, Bennu is easy to reach. It takes about 14 months to orbit the Sun and comes close to Earth once every 6 years. To get there, OSIRIS-REx was launched in 2016 on an Atlas V rocket with a single booster and a Centaur upper stage. It also got a big assist from Earth's gravity in 2017, allowing it to match Bennu's orbital tilt. The second reason that Bennu was chosen was its size and spin rate. Bennu measures about half a kilometer in diameter and rotates on its axis once every 4.3 hours, which is actually pretty slow compared to many smaller asteroids. This allowed OSIRIS-REx to map Bennu's surface up close, and to match its velocity, briefly touch down, and collect a sample. Before OSIRIS-REx arrived, scientists thought that Bennu's slow rotation meant a low risk of flinging away most of its sampleable material. But shortly after arrival, Bennu was caught on camera ejecting hundreds of pebbles. It turns out that Bennu regularly sheds small particles, but it still had plenty of loose material left on its surface for sample collection. The third reason for choosing Bennu was its composition. We don't know what ingredients were present during the formation of life on Earth, but primitive asteroids like Bennu serve as time capsules, preserving material from the dawn of the solar system. Spectrometers on OSIRIS-REx confirm that Bennu is rich in carbon-based molecules, including organics that are the stuff of life. When the Bennu sample is analyzed, it will help scientists to better understand the formation of the solar system and our own origins. So why this particular asteroid? Proximity to Earth, the right size and spin, and a carbon-rich composition. That is why we chose Bennu. As you can see in the bottom of your screen, that SRC is continuing its transit to the clean room.
Awesome.
All right, so turning our attention back to the rocks in the Bach, I have to ask Jim, how did they get it in here? What is this?
So this is the TAGSAM sampler head. It's about 1 foot long. It looks like an old Chevy carburetor, but inside is something much more precious. Inside, maybe 250 or more grams of that primitive material from the asteroid. And it has all the gear on it, including samplers on the bottom, little pads to grab sample, as well as the stuff inside that contains the bigger pebbles and all the dust. It even has witness plates that we use to do that contamination control that Jason was talking about. This is the box.
Mm-hmm. This is the big deal right here. And you know, the material went into this box. We've actually got some of what's called simulant here, and this is obviously not the actual sample from Bennu, but it is a good approximation. Is that right, Jim?
That's right. And so what we discovered on this amazing mission was the material properties and the microgravity of asteroid Bennu didn't behave like we totally expected. They behaved like a almost cohesionless fluid. And so while I pour this here and they fall pretty naturally, and this is about the amount of stuff we expect to find inside this sampler head, they flowed more like water on Earth than we expected there on the asteroid. This is new physics. We didn't know that was going to happen. And these rubble pile asteroids are teaching us something at every step. In fact, some of these bits, which are simulants here, may behave more like little balls of styrofoam than the kind of rocks we have here. So we're going to learn new stuff by just doing basic characterization of the goodies inside this sampler head.
And one thing I think is so cool is that, you know, on Earth it poured directly into this other beaker here, but as you said, it acted almost more like fluid.
Exactly. We actually, when we took this sampler head on the TAGSAM, we pushed it into the asteroid, gave it a poke, let loose the gas, and let the stuff flow. We actually penetrated 50 centimeters. That's more than almost 2 feet. So we went deep into the asteroid, fired our thrusters, and backed away with the sample intact in this sampler head. That was cool. We didn't expect that. We expected contact, 5 seconds later, grab the good stuff and come home.
Right.
So dynamic interactions, learning about how these objects work. As you heard from Lori Glaze, this is how we get to understand the worlds that we need for planetary security.
And I've even heard this described as a ball pit. That's how loose the material was when they approached Bennu.
Exactly. If we had kept going, we didn't have that smart spacecraft, all that great engineering, we could have engulfed ourselves in this rubble pile stuff. Not good. But no crap happened, and we're on the way home, and we have a sample that's coming here to the clean room right here a mile away.
All right, fantastic. Well, now that the team is bringing the SRC back to the clean room here in Utah, what can we expect?
So the next step is really important. We'll wheel that special apparatus that's carrying sample return canister with this thing inside it right to the clean room, bring it in, take off the elements of the aeroshell. That's the thermal protection system in the back shell. We'll take those off and set up the plumbing to get the nitrogen purge on this particular sampler head. That's critical.
All right, that's next. All right, let's get an update from our gal in the field. Take it away, Sophia.
All right, let's put these puppies down.
Lauren, things are much quieter over here now. But for those of you who are just tuning in, this is where the helicopters departed that were carrying our teams of experts that are now having been through a large part of the recovery process today. But really, that's all I have for your updates here from Wig Mountain, overlooking that vast landing zone. But if you do see, we are miles away from the live broadcast hangar, and it took me 30 minutes to get that 12.5 miles, and that gives you an idea of how long it takes to traverse this tough terrain, which is also why the recovery teams chose to use helicopters to get that capsule safely to the clean room. I luckily had a chance to talk to the pilots of those helicopters just the other day, so let's take a look. The OSIRIS-REx sample return capsule just endured a lengthy 3.8 billion mile journey. But the adventure doesn't end once it touches down. The landing zone itself is so large and the terrain so difficult to navigate that the recovery team delivers the capsule to the clean room by helicopter.
Joe's going to be the man hauling the capsule out on the long line. And then Ryan McDonald is another member, and he will be hauling scientists along with myself, the rest of the capture team.
So Ben, can you tell me about the actual procedure of taking the capsule on the long line?
It's a 100-foot long synthetic line. It's got an electrical cord with it. That will hook on the belly of the helicopter. There you go, point it out.
Right here.
Yep, that's the hook that the line will go on. The pilot will lower this hook down to pick up the capsule. They'll fly it back to the clean room, lower it down, and when he lowers it down, he'll hit a little button on his collective. It'll release that hook, and he'll fly away with the long line.
This is not a normal ride. Can you show us how you fly this for this particular mission?
Yeah, so in this helicopter, when we're doing vertical reference, that's what you call it when you have a line on. Now to see the end of the line, I'll be leaning out like this. It's an awkward position, and kind of lean out and look back because my hook's going to be right down in the middle of the helicopter. It will be this button. This button here is the remote hook, and that will keep the line on the belly, but it'll open that little green remote hook when you push it forward.
The experience of these pilots is all a part of preserving this pristine sample of ancient solar system material. And we all cannot wait to see what chemical compounds the capsule holds.
We're now joined by Robert Lightfoot from Lockheed Martin Space, representing the team that built and flew the OSIRIS-REx spacecraft for NASA. Robert, welcome.
Well, thanks for having me. What a great day. Pretty exciting.
Hey, Robert, thank you.
Pretty exciting.
So this spacecraft has many firsts and some unique tech as well. Can you tell us more about some of the new technologies that were integrated into OSIRIS-REx?
Yeah, you know, there's three that come to mind for me. The first is obviously the touch and go sample collector, where we had to come up with what we called the pogo stick. How we're going to hit the asteroid and collect the sample. So that was the first thing. The other thing, we had a natural feature terrain activity that we did that was really associated with, it was kind of a backup for guidance and navigation, but we ended up needing it because when we got to the asteroid, you remember there were very large boulders we didn't expect to see that we had to fly through. And then finally, probably the most unsung part was our digital twin. We created a digital twin for the spacecraft, which, if you remember, this was right in the middle of COVID.
Right.
And so being able to do the sample and use the digital twin to do all the practicing before we took the sample was probably those are the three things that come to mind for me.
And Robert, you mentioned the TAG-SAM, that critical pogo stick, and we heard that it all began with a red cup and some conversations with napkins and things. Can you tell us about that?
That's exactly what happened. It was somebody doing, it was a solo cup and some kind of activity that we did there. And really think about some of the most famous missions NASA has done. That's what we've done in the past, is we've used somebody sketched it out on a napkin and the engineers turn it into reality, and then the scientists get their reward.
To use it. Thank you, Robert. What a great story.
What a fantastic story. Well, thank you so much for joining us, Robert, and congratulations again.
Thanks. Really proud of the team, Lockheed Martin team, and everybody for doing
fantastic
Y'all
work.
take care.
Great job.
We're keeping our eyes on ground operations as teams work to secure the SRC, take measurements at the landing site, and get everything ready for its transit to a specially prepared clean room a few miles away. Today's landing is a big day, but to tell you the truth, NASA is starry-eyed about asteroids, and for good reason. Asteroids are time capsules for the solar system and are vital research destinations for learning about our origins and perhaps our futures. While today's events focus on returning bits of the asteroid Bennu, that's not the only asteroid in NASA's plans. Let's take a look at a glittering list of other places we're en route to visit. 1 year ago, on September 26, 2022, NASA's DART mission navigated to the small asteroid Dimorphos and deliberately crashed into it. Dimorphos is a tiny moon orbiting the asteroid Didymos, which is just a bit larger than Bennu and composed of stony material. The DART impact shortened Dimorphos's orbital period by 33 minutes, making it the first full-scale demonstration of asteroid deflection technology. This summer, while the Bennu samples were approaching Earth, technicians in Titusville, Florida were preparing the Psyche spacecraft to visit an asteroid of a different type. Psyche is named after its massive target, 16 Psyche, which is about 400 times larger than Bennu and more than 3 times as dense. The Psyche spacecraft will visit an asteroid that may consist of a significant amount of nickel-iron metal mixed with rock. It will remotely study 16 Psyche's elemental composition, topography, and gravitational and magnetic fields. The mission will provide insights into the formation of terrestrial planets like Earth. Psyche's launch window opens on October 5th. November may be sweater weather for folks in the northern hemisphere, but for the Lucy mission, things will just be heating up. On November 1st, Lucy will train its cameras on the main belt asteroid Dinkinesh. It will take pictures while rapidly flying by and test its ability to track asteroids during high-speed encounters. The Dinkinesh flyby will prepare Lucy for its next encounter with the main belt asteroid Donald Johanson in 2025. In 2027, Lucy will begin its long trip through the Jupiter Trojans, 2 swarms of primitive asteroids trapped in Jupiter's orbit that are thought to be the fossils of planet formation. As the weather starts to cool down, hold on to your hats. It's going to be an asteroid autumn to remember. A lot of work obviously went into getting this special delivery to Earth, but our pursuit for scientific answers is just beginning. Joining us now is Danny Glavin, co-investigator on the OSIRIS-REx mission. Danny, welcome.
Thank you. Great to have you, Danny.
It's great to have you.
We got samples.
We got them.
It's incredible.
You know, so Danny, as somebody who looks for the building blocks of life in extraterrestrial materials, what are you expecting to find in the Bennu sample?
Yeah, so I mean, we're definitely looking for the building blocks of life, and we've been studying meteorites that we think look like Bennu. And so I'd fully expect to find amino acids, the building blocks of proteins, sugars, and energy source for life. Nucleobases, right? Parts of the genetic code. So we'll see what Bennu tells us. One thing I've learned from this mission is so many surprises. Sample analysis probably won't be an exception. We're going to be surprised.
So Danny, I want to talk to you about some of the new techniques you're going to use, but I'm going to introduce a guest we have. This little guest here is actually a meteorite from Mars, and you've looked at those.
Yeah.
This is a new one. We know it's from Mars because measurements from Viking and Curiosity tells us that. But it's, it's taking the ride from Mars here that Mother Nature gave it. So can you kind of talk about the techniques you'll use on those primitive materials that we have on the samples from Bennu versus those you use on these meteorites like from Mars?
Yeah, actually, they're going to be some of the same techniques. We've studied Mars meteorites. Of course, one of the challenges with all meteorites is they get contaminated when they get around. You're looking for the building of blocks of life, and the contamination really makes it hard to tease out what formed in space. That's why this is so special, these Bennu samples. Pristine materials, right? We're going to be able to trust the organic results from these samples.
I just can't tell you how excited I am.
Well, so our Martian gives us the training to know that, to be ready for what you have on Bennu, and to get ready for Mars sample return when we conduct that.
Absolutely. I mean, we've been practicing on meteorites to get ready for Bennu, and we are ready.
They're ready.
We're ready. Let's go.
Let's go. And how exciting a piece of Mars.
Touching Mars?
Oh my gosh.
You'll be touching Bennu.
Well, not with my fingers.
That's right. All
Recovery
right, Danny.
operations.
You got an
Helicopter
update?
1 is approaching the clean room facility with the SRC.
All right, so you just heard we are approaching the clean room facility. Let's toss to James for an update. Take it away.
Yeah, Lauren, this is the final leg of the journey of the SRC. It has been loaded on the helicopter a few minutes ago with a long line to get those operations to bring it back to the Dugway clean room. And in just a few moments, we'll have a nice view from just outside us here as it comes back over. And I can see actually right now we have a view of that helicopter with the SRC attached below coming into view over the Dugway clean room. You can see this wonderful final view. And because we were able to transport it this way, this was determined the most efficient way to actually get this SRC to the clean room. It gives us a phenomenal final view here of that last flight. Truly a parade for this sample return here. And just a stunning view of the Utah Test and Training Range, surrounding mountains. And there's that SRC beneath the helicopter with the long line. There's about 100 foot of that long line there. You heard from one of our helicopter pilots earlier that they do this very carefully. They hang out the window of that plane, or the helicopter rather, to determine the safety of that SRC, making sure that they are continuing to travel properly with this SRC to the clean room. And as we speak, team members are staged and waiting just outside that clean room, ready to get that SRC back on the ground once more. There are team members already in the clean room, gowned up. They've been waiting there all morning. They know what they need to do for this next step to get that SRC in. It's going to actually be wheeled into the clean room. They're going to go through a brief operation of cleaning off a little bit of the thermal blanketing, taking all of that off, and then wheeling the SRC and placing it into that room. They're going to remove the heat shield and the back shell of the SRC and actually get the sample canister out. And you just heard from Jim a few moments ago, the most important next step here is getting that sample canister on a nitrogen purge. And we'll remind you again, that is to keep the sample within pristine, uncontaminated from the atmospheric particles that surround us, getting that sample nice and on that nitrogen purge. Just a great view. You can see it hanging beneath our helicopter there, not spinning at all because of that gimbal that is keeping it stable. Low winds today. And that SRC is bagged in thermal blanketing inside that cargo netting. And in just a few moments, it's going to be lowered down to team members outside the clean room. The first team members to actually approach this SRC once it lands will be wearing personal protective equipment and gas masks once again. They're going to do another safety assessment of that SRC, approaching with those PPE to take gas measurements to make sure that the batteries did not heat up and outgas at all during this short flight. And then once they give the green light, there will be a brief team huddle. And then the next step of the recovery operations will continue. They'll get that SRC onto a small carrying cart, and you can see it being lowered down. The clean room, the top of the clean room, the building rather, is in view, and that SRC is coming down to the ground. Slowly being lowered. Everything about this has been carefully planned out, a very slow process. You can see a wonderful view of the SRC and the cargo netting. That metal piece on the bottom is the carrying fixture that helps team members actually carry this SRC. In just a few moments, the SRC will be back on the ground. Its second touchdown of the day, a much calmer one than we had earlier this morning. And you see two members approaching, grabbing that cargo netting to get the SRC on the ground, and in just a few seconds we will have a release of that long line. And there you have it. The SRC has arrived at the clean room. Claps from the audience in the background there. Very excited to have this back on the ground. And in just a few moments, team members will approach. A very excited celebration. Great to have it on the ground. And this is the last step of the process for today's events, getting that SRC in the clean room. In just a few moments, you'll see team members approaching and beginning to unwrap the gift within. You can see our first team members walking up with that gas mask on. This is once again for team member safety, just to make sure that the operations are continuing nominally, that there are no possible outgassing from the batteries within. The rest of the team will wait for this initial safety assessment before making their approach. And there was some assistance for this step of the process from our team members out in the field. When they bagged the SRC.
Recovery operations. The SRC has been delivered to the clean room facility and is being prepared to transfer into the clean room.
So Zoe is removing the cargo netting now, and she's going to look at those X marks, those tape markers there. They're capped on tape that the team out in the field actually placed on that thermal blanketing. They let her know exactly where the air vents are, the gas vents on the SRC. So she doesn't have to unwrap the whole thing. She can just unwrap that small part and take her gas readings just to make sure that we're not outgassing anything from the batteries within. She'll take, once again, some thermal measurements just to make sure we're at safe operational temperatures. We don't anticipate any kind of additional heating on that SRC. You can see her opening up ever so slowly that thermal blanketing right at that capped on tape. Taking her readings. You can see another layer of that thermal blanketing there, and then the SRC is safely stored within. She's further unwrapping the SRC. There is additional thermal blanketing. You can see there's a couple layers. There's 2 layers of the thermal blanketing and then the tarp over top everything. She just needs to access that interior part and take her gas reading. You can see her with the instrument now taking initial thermal temperature reading. A nod of the head there. Looks like everything is nominal. And she'll take a gas reading here. You can hear the helicopters buzzing overhead here. The rest of our recovery team just shortly, a few minutes ago, landed nearby. And as we speak, on the other side of where Zoe is right now, there are team members preparing the clean room for the last leg of the recovery operations, getting that SRC inside the clean room and beginning the process of extracting that sample canister from within. Zoe continues to assess the situation here for safety. She is beckoning for her team to come over. It seems like it is safe for the recovery operations to continue, and 2 more team members will be joining her to assist with this next step of the operation. And here come a few more team members as well. Approaching now is Rich Witherspoon, who's been overseeing a lot of the operations out here at Dugway. There's been a number of rehearsals. We have a ground view now. Zoe is cleared to take off her gas mask. Big smile, very excited to get that SRC back here. It appears to be safe to continue the next step of the operations, getting that sample return capsule in the clean room. She's putting away her thermal protecting gloves. The rest of the team is there, ready to begin actually getting the SRC unwrapped and onto a small cart that will be rolled over in just a few seconds. Rich just giving the team an update on the status here. They do these team huddles just to make sure everyone's on the same page with the recovery operations. It is always simultaneous action. Everything is perfectly coordinated like a ballet dance. Especially once they get in the clean room, you'll see some of those operations. They are very well choreographed. And you can see they are bagging it up just a little bit more before they do this next step of the operation of actually lifting it up onto the cart that will then be wheeled into the clean room. Everything has really been thought out in advance, down to the actual material of the gloves the team members are to use in actually handling the sample return capsule. Nylon 6 is a polymer which is very similar to a protein, and so when nylon gets wet, hydrolyzes, it breaks up and releases a compound called epsilon aminocaproic acid that can be seen in some meteorites. So in order to distinguish between the chemistry that we see on Bennu and the chemistry that we see on nylon degradation, we need to make sure that these sorts of classes of compounds are kept away from the sample. So nylon gloves are not to be used. The gloves you see the team members wearing are made out of nitrile, which is safe to be used. And you can see 2 of our team members carrying that sample return capsule over to our clean room, our camera crew following behind, documenting this whole process. And you can see that cart in the background there. This is to help the team wheel the SRC into the clean room. That big metal door there will be open for just a few moments, and the team will wait just for the dust to settle. It'll kick up a little bit of dust, so they want to wait for that to settle and be visually clean, is the way the team describes it, before they continue to wheel that SRC in further, removing the tarp covering that thermal blanketing protective layer of the SRC. And you can see on the other side of the door, the team members for the clean room team are waiting to acquire that SRC within. and one big lift. All 4 members really digging down underneath there, getting that SRC up onto that fixture. A bit of a heavy lift, you can see, and we have it successfully on there. There's some padding protecting that SRC as it rests lightly. You can see the white padding underneath the SRC. In just a few moments, teams will await clearance to open those gates, open that door, and get the SRC inside the clean room, getting it on that nitrogen purge. Just a few moments later, a knock on the door, and there it is. The clean room door is opening up. Our Johnson team on the other side waiting for their precious cargo to arrive, and it is wheeled into the door. We have the SRC inside, just sitting outside the clean room. You can see at the left of your screen with the NASA meatball and the OSIRIS-REx insignia. That is our portable clean room that has been set up here at Dugway for the sole purpose of this part of the operation. This last step of the process of getting the SRC opened up, accessing the sample canister within, getting it on a nitrogen purge, and then actually tomorrow morning we'll have a C-17 cargo plane flying this precious cargo down to the Johnson Space Center. At the Johnson Space Center, they've actually built a custom clean room for the OSIRIS-REx Bennuis samples. As I mentioned earlier, they're going to be joining a historic collection that also includes samples from the Apollo program that were collected at the surface of the moon, as well as samples from Stardust and Genesis, both of which actually landed here in the Utah Test and Training Range a number of years ago, and also some Antarctic meteorites. We will not actually be opening up the sample canister today, so that we'll actually have to wait just a few days, so the team will have to be patient still as they wait for the official opening of the sample canister. But what you're seeing now, a bunch of team members will lift up the SRC for our curation team to reach underneath, scrape off any kind of dirt, and place it back on to our carrying fixture here. All of these samples will then be looked at as well. Any kind of environmental samples that potentially came in contact with our SRC are of interest to the Johnson team, so all of that will be documented for later as the team continues to shed the thermal blanketing layers that were protecting our SRC on its journey on the long line. You can see a couple team members looking through the windows of the clean room, waiting for their part of the process to kick off as they get the SRC wheeled in. We get a nice close-up view of the SRC here. You can really see how charred it is from that entry into Earth's atmosphere. That is the back shield that you're seeing of the SRC, and the top part there has been sealed off. That is actually where the parachute was deployed from. See, there's that yellowish orange seal that was placed on top there where the parachute disconnected from the SRC. A brief team huddle here as they walk through the next step of the operation, making sure everyone is on the same page here as they will lift up the SRC ever so slightly, and the team has these brush tools. You can see one of our curators carrying one in her right hand there. They'll lift up the SRC, and she's going to scrape off any dirt from the Utah desert that was on the bottom. That will actually then be certainly of interest to the curation team as they begin to analyze the sample we got back. You can see they're giving it a little brush. Very charred surface of that SRC. That metallic portion below is the heat shield, which protected our sample on its journey through Earth's atmosphere to the Utah Test and Training Range. And you'll see a lift of that SRC for team members to access underneath, checking for any dirt. It doesn't look like we really had any develop. And this is actually great because what happened was, since the soil was so damp today, we had a little bit of moisture. It was actually a much softer landing, so not as much dust really caked on that SRC. It landed perfectly on the surface of the Utah desert. They're going to place this back down again. Seems like their operations are going perfectly according to plan here. They'll do another lift on the other side just so they can access where the team members were previously holding. And then if all looks good, they will clear this to be wheeled into the clean room. And really just backing up and thinking about this entire journey from where we started this morning. Right before, maybe about 4 hours before we kicked off our broadcast, the team at Lockheed Martin gave the go to release the SRC that you see right here from the main OSIRIS-REx spacecraft. It detached from that spacecraft on its 4-hour solo journey. There's nothing we could do at that point as it entered into Earth's atmosphere. Began the punishing entry, descent, and landing, which took us to the Utah Test and Training Range. Out in the field, teams worked to recover the sample, and they actually continued to take samples, environmental and air samples of the region around where we landed. We successfully bagged this sample return capsule in thermal blanketing that you see right there beneath the SRC, that plastic-looking material. We transported it successfully with our long line operations. Big thanks to our helicopter crew today for helping us get this sample return capsule to the clean room. A couple more lifts here you see, and they're going to remove that last layer of thermal blanketing, placing the SRC on its own without any layering onto our carrying fixture. You can see just how charred up those gloves look. A lot of that char from the heat shield getting off on their gloves. You can just see how dark it is. Really heating up. Initially, when we hit the Earth's atmosphere, we were at over 5,000 degrees Fahrenheit. That's about half as hot as the surface of the sun. Quite warm. It's cooled off substantially, so obviously, as it's been transported throughout the day here, and is now just moments away from getting transported into our NASA clean room that you can see on the right of your screen. Team members are all gowned up, and inside that clean room there is a fixture dead center that this SRC will be placed on that will allow the team to be able to gather around and begin to open up this nesting doll protective layer, the SRC, to access our precious cargo, that sample canister within. Again, they want to make sure that everything is clear before they wheel this in. Everyone's ready to go. Everything looks good before they wheel that sample return capsule into our clean room. Just truly an incredible day, and the science that's within these samples is truly hard to fathom right now, just how influential this science is going to be. Keep in mind, these samples are from the origins of the solar system, billions of years ago. They hold the clues to how everything around us came to be. And in just a few short weeks, scientists will begin to analyze these samples and stow away even more sample for generations to come. Future scientists will be able to open these samples and continue the journey of OSIRIS-REx. As we speak, this incredible mission still has not come to an end. Our spacecraft, our intrepid robotic explorer OSIRIS-REx, is now dubbed OSIRIS-APEX, heading to the asteroid Apophis in the year 2029. Obviously, we do not have that sample return capsule or the sample tag SAM, which actually helped us collect that air filter looking thing that helped us collect the samples at the surface of Bennu. That is no longer attached because it's sitting right here in our clean room. But the mission will continue. The team will map the asteroid Apophis in great detail, similar to what we did with Bennu, descending down to the surface, firing its thrusters, kicking up a sample. And as we speak, the sample that it got from Bennu back in 2020 is just moments away from being wheeled into the clean room. The team doing one more sweep, cleaning off those wheels that came in contact with the pavement outside, just before getting this SRC wheeled over into the clean room. Just truly an incredible journey of this mission. 3.86 billion miles total to Bennu and back with this sample. And now it's just a few feet away from our clean room. You can see on your screen too some of the gas coverings to those vent covers that were placed out in the field that prevented any kind of contaminants from getting into the SRC. And as I mentioned before, that SRC is a nesting doll of sorts, very protective, and within there's a complex network of tubing, labyrinth-like tubing, preventing any kind of contaminants from getting into the sample. But the team still wants to get that sample canister on a nitrogen purge. That will ensure that it will stay clean, pristine from any possible atmospheric contamination. It's going to stay on that nitrogen purge all the way through its trip down to Johnson Space Center, where ultimately it will be opened at their curation facility. You can see in the bottom left of your screen our team members inside the clean room, all gowned up. And right at the bottom there, that kind of goldish bronze looking fixture is where this SRC is going to be placed for the next step of the operations. This, as everything has been, is a very careful process, choreographed every step of the way. Team wants to ensure that everything is cleared before they wheel that in. We are just moments away from that wheel of the SRC into our portable clean room. You can see in the background in the pink shirt, Jason Dworkin observing. He is one of our astrobiologists from NASA Goddard. He will be looking at these samples along with hundreds of scientists from around the world, helping us better understand the origins of our solar system. The anticipation builds for this final moment. A massive sigh of relief at this part of the way, because we have that SRC now not only on the ground but just inches away from our clean room. The team looking inside there just to ensure everything is good to go. Get a great shot of that NASA meatball and the OSIRIS-REx logo on the doors of the clean room. The operations at Johnson Space Center, once this sample canister is transported there, will be truly a sight to behold as well. In just a few days, we're actually going to get our first science results from the sample within. And as I mentioned, they built a custom clean room at the Johnson Space Center for this very purpose. The team that you see on screen here has been rehearsing at that clean room, preparing for the big event of actually getting that sample opened up and beginning to parse it out and ship it to labs around the world, stowing a lot of it for future generations. Truly an incredible amount of science that we can't even begin to imagine is trapped within those rocks. And I personally am very excited to see exactly how much sample we got back. The original mission requirement was a mere 60 grams. We had an explosive tag event at Asteroid Bennu back in 2020, excavating over 6 tons of material when we contacted the surface and stowed potentially 250 grams of sample within that tag SAM device, that air filter that Jim was just showing a few moments ago. There are also no radio frequency signals allowed inside the building that you see here too. The building is on ordnance protocol. They want to make sure that everyone is safe here, that there could still be active ordnances from the parachute deployment with the OSIRIS-REx spacecraft. We had a mortar fire to release that parachute, that orange parachute that took us the last stage of our journey to the surface of the Utah Test and Training Range. Crew members pacing around inside that clean room, waiting to get that SRC inside. And so when they actually open up the SRC, removing that back shell, the sample canister, they will attach a couple tripod-looking legs to it, these small legs that will allow them to flip it over onto a table nearby. You can see that metal table in the back of the clean room. And at that point, they're going to put it on a nitrogen purge. You can see they're moving that fixture a little bit closer to the door because they're just going to lift that SRC off of the carrying fixture and place it onto the clean room's fixture. It's a quick little transfer, very quick opening of the doors. In just a second here, you can see our team members moving that a little bit closer. The doors are now open. We are entering into the clean room, and that SRC is about to be moved off onto our clean room fixture. Our clean room team members carrying that SRC in, and these doors will be slammed shut just as soon as we can get that SRC fixture out, and there we go. It is in the clean room. The SRC from the desert of Utah, earlier this morning arriving, has been successfully delivered to the Dugway portable clean room. And you can just see just how charred that SRC back shell and heat shield are. A great close-up angle here. You can really see our prized sample return capsule at long last in the clean room. It's hard to fathom that just a couple years ago, this sample return capsule that you see here was over 200 million miles away from us on the other side of the solar system. The OSIRIS-REx spacecraft worked to quickly stow the sample it got from the asteroid Bennu at sample site Nightingale into this sample return capsule. We slammed that lid shut and prepared it for the long journey back. It took 1.2 billion miles to get from the asteroid Bennu after sample collection to Earth's atmosphere. We entered in 82 miles off the surface of San Francisco, went through the punishing entry, descent, and landing, landed in the desert, and now here we have it, the sample return capsule in our clean room. The team's going to move this a little bit over to the center of the room so that they can all gather around and begin the process of removing that back shell and then ultimately getting the heat shield off as well. So what's going to come up next here is that back shell that you see there. The team will remove that, get the sample canister that is within. It's a complex network of tubing to get to that sample canister, and this is also, like I mentioned, a nesting doll of sorts protecting our sample within. They're going to get that sample canister out. They're going to get it on a nitrogen purge. That is our safe point. That is what we're looking to get to today. As soon as we're there, operations for the day will effectively be completed. Tomorrow, the SRC, the sample canister rather, will be flown on our C-17 cargo plane down to the Johnson Space Center, where in just a few days, it will actually be opened up for scientists to be able to see the sample within. It's been incredible covering the moments of today, the journey of our SRC from Bennu to the desert of Utah to our clean room. And for now, back to you, Lauren and Jim.
James, your coverage has been impeccable. We could not have done it without you.
Go, James.
So to be clear, the newly redesigned Apex mission will not be touching down on its destination asteroid Apophis. The big reason for that, of course, is that the vehicle's single-use sample collection device just arrived here on Earth, containing samples of asteroid Bennu. After more than hundreds of millions of miles in space, that sample will now travel a few hundred more miles to a specially prepared home where experts intend not only to study it, but also preserve it for future generations. That facility is the purview of our next guest. Eileen Stansberry is the chief of the Astromaterials Research and Exploration Division at the Johnson Space Center. Welcome, Eileen.
Welcome, Eileen.
Welcome.
Thank you.
How about that? Did you check out that all of that cool movement between the clean room and everyone preparing it?
Absolutely. It's so exciting. Anytime you get samples back, and being here today to receive the Bennu samples is a highlight. The team has been extraordinary. The work that all the variety of participants, team members, teammates that work on this mission have been extraordinary. From the flight teams, the mission development teams, operations, science, curation, all working together to bring these samples home to us. And it may seem as if it takes a lot of time getting into the clean room and processing in the clean room, but a lot of that is because of preserving the contamination, the scientific integrity, minimizing the contamination on the samples. Clean room protocol is always slow and methodical to allow any dust or particles that gets generated or any of the debris from the back shell to settle before you do the next step. So all of these steps are very carefully choreographed to ensure the scientific integrity and maintain the pristine nature of these samples.
And you'll be doing, Eileen, when you receive these in your laboratories at Houston at Johnson Space Center, you'll be doing the next phase of that very special curation. Can you tell us a little about that?
Yes, we have a special facility that was designed in particular for these samples to have all of the appropriate materials restrictions to make sure that these particular samples stay pristine for generations to come. As stewards of the scientific value of samples, we manage samples for future generations in addition to the current science that is available on these samples. So the first thing that we will do is bring them into one particular clean room, let it settle, and we will transfer the sample canister from one level of cleanliness progressively to next level of cleanliness to ultimately a continuously purged nitrogen glove box. So what they're doing here in the clean room in Utah is to remove the contaminating potential of the heat shield and back shell that were charred during reentry, and get the sample canister on purge,
Right.
to have nitrogen continuously flowing through that canister to ensure that there's no earth contaminations that will leak in, even though the likelihood of that is vanishingly small, making sure that there's a continuous nitrogen purge. So that nitrogen purge will stay on the sample canister until it gets into the nitrogen glove box in Houston, where we will start deintegrating the sample canister to get to the precious cargo inside.
Which are inside the sample head, which has...
Yes.
Right, okay. Right.
But there is the possibility of some samples being within the sample return capsule, this capsule here,
right.
Because the Tag SAM event worked more well than we had anticipated.
Right.
There could be some sample of Bennu within the sample capsule.
Wow.
And so we will make sure that that sample also gets identified and safed to maintain its integrity here, so that it also retains its value.
Wow.
Amazing.
What an opportunity. We may have more goodies than we thought.
Yeah, we thought.
Jeez,
Amazing.
Eileen.
Well,
Good
Eileen,
job.
thank you so much for
much.
joining us today. We've loved having
Thank
you.
you.
Right, really, Eileen, congratulations. Way to go.
Thank you, and we're so excited.
Your whole professional life has been planning for a future event, and then suddenly that day arrives, like today, which is probably a perfect segue to be bringing up something that may come as an unexpected surprise to mission fans. Today may be the conclusion of flight operations for OSIRIS-REx, but the mission is not exactly finished.
After ground teams retrieve the capsule, the Bennu samples will be taken to NASA's Johnson Space Center in Houston, Texas. The sample canister will be opened in the Astro Materials Acquisition and Curation Facility, and the samples will be curated, distributed, and studied for decades to come. Having delivered its cargo, the OSIRIS-REx spacecraft will depart Earth, but its journey will not quite be finished. In a daring encore, the renamed OSIRIS-APEX will enter an elliptical orbit of the Sun, repeatedly passing within the orbit of Venus and pushing the limits of its thermal design. Beginning in 2029, it will chase down and investigate Apophis, a 1,200-foot stony asteroid destined to make an exceptionally close flyby of Earth. After 13 years in deep space, at the start of a new decade, alone on a new world, the journey will continue.
Jim, OSIRIS-REx collected its samples and is bringing them back to Earth for analysis, like we've all watched today. But how else is NASA planning to analyze its other samples?
So, as you heard from Eileen, OSIRIS-REx in Houston will start the sample preparation around hundreds of labs later. It's going to be fantastic. We also sometimes bring our laboratories to the samples themselves. Curiosity rover. She's carrying a huge payload, not unlike those we'll use in laboratories here. Sometimes we go to new places to actually bring the labs to study samples that we can't bring home. That's our new wrinkle.
And on that note, when I consider how many places there are to visit, I'm aware that a guy like you is probably weighing all of the choices, about where to go. So speaking of which, you are the principal investigator for a new mission called Da Vinci, which for those at home, principal investigator is basically the big guy in charge. So what is this mission about?
So Da Vinci is a mission to Venus. You can see it in the morning sky, and we haven't been back to the Venus atmosphere and all the complexity and how that formed and evolved literally in a generation. So together with a very big team, it's not just the PI. I mean, Dante is the gold standard PI for all of us, but with our team, we're going to bring a spacecraft with the kind of instrumentation we'll be using on the samples from Bennu and from Mars to the samples in the atmosphere that will tell us about the assembly of that atmosphere, whether Venus had oceans for how long, and come under the clouds and see the mountainous regions and their chemistry for the first time in history. And so we're excited to pick up on the great news from this mission, OSIRIS-REx at Bennu, and some Mars exploration, and take that forward to Venus so we'll get the next generation interested in our sister planet.
So everybody stay tuned for that one. So Jim, you've also been the PI of several previous missions. Put yourself in Dante's shoes. How would you feel today?
Dante must be both overwhelmed and overjoyed. He's probably, as my wife says occasionally about me, beyond words. And he's been waiting literally his professional lifetime for this. It's here, it's happening, the science is going to flow, they can't miss. Honestly, I am sure Dante and his team are just sitting on pins and needles waiting for the transfer to Houston, all that stuff Eileen said, so we can get to work. This will be epic.
And Jim, not only are you the PI of Da Vinci, but you actually had a hand in OSIRIS-REx as well.
Well, way back in the dark mists of 15 years ago, we were all wondering how we can sample things as hard as asteroids like Bennu. And people like Dante and others had generated the idea we were all talking, because we wanted to think, how do we sample the solar system? Cruise to the moon, great. You know, giant sample return systems to Mars, fabulous. But these small bodies are also important, and they've been a priority for our National Academy. Cometary nuclei, asteroids like, of course, carbon-bearing ones like Bennu. So when those folks got together, we were all in conversation, and they proposed mission ideas, and some of us were able to participate in very small ways to help them get these missions going. It's just a thrill to see them succeed so well.
Especially after 15 years. As you can see, Jim is a wealth of knowledge. So on that note, we're getting questions from around the world about this thrilling mission. Let's take our final questions of the day. All right, at Oatmeal, today is my birthday. Can I have some of the asteroid sample? It would mean a lot.
Well, you know, you heard there's other birthdays today, too, including the Colonel.
I think Oatmeal saw that it was also Colonel Harwell's birthday.
But as Danny Glavin and Jason said, you know, the samples from Bennu are for scientific research, education, inspiration. They'll be used, you know, for future generations even, as Eileen said and Jason said. So, unfortunately, we can't give you Bennu. We can give you pictures and up-close vantage point like we've given you today, and as the science is done by the science community, and so you'll be part of that, and you can write proposals to work on samples if you have a neat new instrument you want to try. So stay tuned.
Stay tuned. And I understand, Oatmeal. I also want a piece of that sample,
yes.
But we got to, you know, we can't. All right, Jim, let's take one more. All right, at Electromanicia, I hope I got that right. What questions are we hoping to answer by studying the samples from asteroid Bennu?
Well, fantastic question, and there are many. It's all in the name. So we want to look at those building block chemistries of the earliest solar system. It's all eradicated here on Earth. We have to go to places like Bennu or other asteroids like it to get those records. So we're going to look in the deep time to understand our solar system from those chemicals. We're also going to look at how we use a real asteroid stuff to understand what we see of other asteroids through telescopes and flyby spacecraft. That's the ground truthing, or the asteroid ground truthing that we do. We're also going to look at resource potential. These asteroids contain bound water in minerals. Those are really cool. You can get the water out. That's neat. Also, interesting distribution of metals. So this is a really exciting opportunity to put that all together and also understand the mechanical behavior of these objects. They're rubble piles held barely together flying through space. So we're going to do all of that and answer questions we haven't even thought of yet. Dante's team will invent the questions for the future from what they do with these samples.
Fantastic. All right, I think we have time for one more. Let's take a look. At Horrors of Cody, is there any worry of possible bacteria or virus from the sample, regardless of the clean room?
So that's a very good question. And of course, the team, and you heard from Jason Dworkin and others, have been thinking about that for a long time. We think these types of asteroids and the materials from them are not life-bearing. And they're not life-bearing, and so we have classified this mission as a certain class of planetary protection. So we're not expecting any true life-bearing biological elements to be a part. But the fragments of organic chemistry, carbon-bearing stuff that you heard Danny Glavin talk about, the building blocks of life that got it all started in all the places it is here, but also maybe elsewhere, really important. So we don't expect to see any of that. We've contained the contamination. You see what's going on now in the portable clean room and at Eileen's place back in Johnson Space Center. So we're very optimistic. No worries about that stuff. We're good here.
So I think we talked about this a little bit, but I think one thing people are maybe wondering, or even maybe a little worried about, is could this sample contaminate Earth? Are we at risk of something catastrophic?
Literally so vanishingly small that no one would rightfully bet on anything like that. This is space, rock, and dust from a time so far ago that's been baked in the space radiation that wouldn't be good for any any living thing, sorry. We're all organic. And so it's been sterilized by being in space, in effect. And we do the same thing when we go and sterilize stuff that we'll bring back from planets like Mars. So.
How long is this next process going to take? You know, we're in the clean room now. We're going to go to Texas. How long is this all going to take before we start getting some results?
So, in the next few weeks, in the next couple of weeks, by October 11th, we expect the team in Houston, Eileen's team, and together with Dante's team, will have done that first proper containment and understanding all the possible sources of contamination, so they can document those for the future and also make sure they're through all those gates that Eileen was mentioning, so the samples are protected from anything from Earth, so they won't be contaminated. Then they'll do some first characterization with all these great machines they have in Houston, and we'll start talking about what they get by the end of October, going into the Christmas time. And by the end of January, I've been told the science team meeting, the sample leaders will start reporting to all of us what's going on.
Wow, that is soon. And you heard that Unboxing Day is October 11th. Did I hear that
That's right.
Okay.
It will be a Christmas party for samples.
Okay, that's right. So, Jim, I'm struck by how these last few minutes compared to the last few years. You know, here we just saw human hands wheeling precious scientific, cargo at walking speed through Earth's atmosphere.
Exactly. We went from cosmic velocity to velocity smaller than an ant would use to crawl across the table to pick up a crumb. And so that's the speed of science. To get it, the engineering flies, cosmic velocity, sampling, all that great dynamics, and finally now the careful, methodical, snail's pace to get it done right so we preserve it. I mean, this is like geoarchaeology of samples from a place that's not Earth. Very special.
Yeah, absolutely. The sample return capsule isn't done traveling, of course. Once it gets stabilized on what's called a nitrogen purge to ensure everything remains dry and uncontaminated by intrusive gases, the entire apparatus will be loaded aboard a C-17 cargo plane for a flight on its way home to Johnson Space Center. Once it arrives, scientists are ready to start working on vital research on this extraordinary sample of the asteroid Bennu. But that airplane ride and the research plans waiting for it on the other side starts tomorrow. For now, the OSIRIS-REx sample return capsule has completed its solo journey of nearly 4 billion miles, landing in the Utah desert, and is now in the expert care of our on-site sample curation team. But we're not out of the woods yet. We did mention this nitrogen purge.
That's right.
So
we have to carefully contain this so we can do that work and literally, really transform knowledge for all time. This is the thing that we dream of, and Dante and his team, 10 years ago, were thinking of that. Transformational knowledge that will change how we think of ourselves.
And we couldn't let you go before we share something fun. So we just delivered a sample of the asteroid Bennu back to Earth, but the UPS can also deliver fun stamps of the actual asteroid Bennu sample return. Let me turn that over so you can see it on this side. How fun is that?
So we have brought an asteroid first-class delivery from OSIRIS-REx to Earth, and our postal service here in the United States is issuing stamps to build on that inspiration so they can deliver our packages for us.
How exciting. I know, everybody needs to get some of these.
Yeah.
These are really cute.
Yeah, I want one.
I would like one too. As we're wrapping coverage here at the Utah Test and Training Range, let me remind you that this is not the end of the story. Next up is our post-landing news conference scheduled for 3 p.m. Mountain Time, 5 p.m. Eastern Time on NASA TV, presented live right here on nasa.gov and other streaming sites. You can also find mission updates on X at NASA and on the web at nasa.gov. That's all the time we have for today. Jim, it has been a pleasure sharing the stage with you. We did it.
Way to go. Thank you, Lauren, for having me.
And a huge thank you to all of our guests for joining us today, and a warm thanks to all of you out there for watching us. Here are some highlights from today's exciting landing. Special coverage of America's first asteroid sample return mission, OSIRIS-REx, as it arrives back to Earth after more than 7 years traveling in deep space.
We see
PDL milestone. We have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. Disconnecting from the back shell, we'll then actually unwrap all of that thermal blanketing once we actually get it into the clean room here.
Recover the operations. SRC is in the cargo net, and all the gear has been stowed in the helicopter.
Special coverage of America's